Alright, so welcome to another Linux kernel module programming tutorial. Alright, so in this tutorial I promise that we're going to get into actually writing a module. First thing we want to do is open up a terminal. Go ahead and make a directory that we're going to be storing everything inside of. I'm going to call mine module. There's nothing inside the file. Alright, so at this point in the game, we're going to make a file and call that file hello. Okay, so at this stage, what we want to do is create a file called hello. And we're going to call it hello.c. You want to do include Linux int. This is for initialization of the module, and this is for being able to recognize that this is a module. So at this point, we want to be able to initialize the module, and at the same time, when we're done with the module, be able to clean up any resources that we've used while the module has been running. And we simply do that by making two functions. It needs to be static because there can only be one instance of these methods. And one thing to mention is that Linux kernel programming is done entirely in C, with some small bits and pieces done inside of assembly. So that's why I have this weird syntax present here. Just give it a void. Per the signature of initialization, it needs to be an integer type and hello. For the macros to be able to accept this definition without complaining. And next is something new. And when you're doing Linux kernel programming, you cannot use user space C library calls like printf, scanf, and any of those types of inputs and output mechanisms. You cannot use any C library functions, period. So to be able to display information to the console, we have to use print k instead. And it's not really printing to the console, it's going to be printing to a file, a log file that's kept. And we can later use something like dmessage to display those log information to the console. So this is going to be the entry point for our application. And so what we want to do now is say that when this module gets loaded into kernel, we're going to display a simple message. And we're going to say alerts, and then say hello world. And this basically just displays a message. This kernel alert is used for prioritizing log information. There are different versions. Static. When we're done with the module, we need to deallocate resources that we've used by saying static void. And again, it needs to be void or static because there can only be one instance of entry into the kernel module and one instance of exit. And here we're going to display another message saying kernel alerts. And that's it. At this stage in the game, this won't really do anything to be able to, because whenever this gets loaded, it won't be able to start executing. You have to tell the Linux kernel where to start executing your Linux module. And we simply do that by saying module int, and we pass it the pointer, the address of this function by just using its name. So this tells it whenever you start this module, jump execution straight over here. And then next we're going to say module exit. And I'm sure you can figure out what this one does. Whenever execution is done, or whenever the module is removed from the code jumps its execution straight here and deallocates any resources that have been used, so we keep the system clean and fresh. Now we have to actually build this source code into a module. Okay, so next what we want to do is make a makefile to build our Linux kernel module. We do it by saying gedit makefile. This is what the makefile is going to look like. That's the file that you want to create. So this is what the makefile looks like. First line is going to be basically the name of the Linux module source code. Instead of C, you can put O. And then this is going to be the directory for your Linux headers. The source file, the Linux kernel that's currently running, you want to compile it against the headers available for that Linux kernel. So mine is going to be usr-uname 3.2.0 generic PAE. And if you don't know which one you're running, you can simply say uname.r, and this will give you it will give you a hint as to which header file that you need, and then you can do ls usr.source, and then you can simply find which one that you're looking for. And mine is here, and that's what that's how I arrived to this location. Okay, next to build it, you're going to say make -c and the kernel directories, the subdirectories, and modules. And this command here is for cleaning, as to remove all the executables that are generated after typing make. So you want to save that and exit. At this stage, all you have to do is type make, and that will start building the Linux module. Okay, now simply all you have to do is say insert mod hello.ko. That inserts the Linux module into the Linux kernel, and then dmessage will display the message, because remember, print k does not write to the console. Likewise, remove mod will remove the module that we just compiled, and then dmessage again to display the messages. So as you can see, hello and goodbye. This was from a previous run of inserting and removing that I ran prior to recording. That's going to do it for this tutorial. Please, as always, rate and subscribe and leave a comment below.